Okay, so brief review on, was this Friday? Okay, my date says Friday. I would say I honestly, my days are kind of blurred together. Okay, on Friday, we talked about whether or not sets of ordered pairs are functions, right? And we also talked about how to find inverses. So, first of all, quick review. How did we find inverses? We were trying to find an inverse. We took the x value and the y value and we flipped them, right? X's became y's, y's became x's. How did we know if something was a function? How did we know? Kendra?
Each x value can only correspond to the y value.
Okay, each x value corresponds to exactly one y value. And so the shortcut, as long as each x value is different, it's a function, right? Our example of something that was not a function is right here, when -3 pairs with 2 and -3 pairs with 3. This x value of -3 paired with two different y values. Okay, so that's just a review because I taught that Friday. It's now Tuesday, and I'm going to ask you to go back in and do homework about this tonight. I know, it's been a while. A lot's happened since then, right? So, now, to continue along, before we flip to the back side of the notes, there are some directions here about finding the inverse of a function. And we just talked about to find the inverse of a set of ordered pairs, we took x's and y's and we flipped them, right? So here we're going to talk about, okay, if you flip to the back side and look, we're going to take equations and find the inverse of the equation. And so a couple of key pieces of information. First of all, the graph of f of x and the inverse of f of x will be reflections of each other in the line y equals x. So if you're trying to visualize the line y equals x, it's stated as the perfect diagonal line. So the line that goes through 0, 0, 1, 1, 2, 2, that line right there. And so if a function and its inverse are truly a function and inverse, they reflect across that line. Now, more importantly, what you guys want to know, how do we find the inverse? And we're going to switch the variables x and y. So every place you see an x, you're going to make it a y. Every place you see a y, you're going to make it an x. And then after we switch x and y, our job will be to solve for y. So just like our typical, when you're trying to graph something, we want to solve for y, get it in that y equals form. That's what we're going to be doing. For an inverse equation to be a function, it must pass some kind of function test. So just like we would check anything else if it's a function. So x's can't repeat is a big one. We haven't talked about, but do you guys remember the vertical line test? Yeah. If it's a function, it passes the vertical line test where we just draw one line and it only touches it once. So those are ways to determine if something's a function. And then when we get down to the end, instead of writing y equals or f of x equals, we're going to write f inverse of x equals. And I don't know if you can tell what that is there, but that's an f raised to the power of -1 is what that is. That's f to the negative first power of x. That's how we write an inverse. Okay? So, let's try our hand at some of these and see how we can do. And we're not going to do all of these A through F. Even on a good year, I don't do all of them because it just gets to be too many. But I'm going to hit some highlights, ones that I feel like have important steps, ones that will relate to things you'll see in homework. Okay, y equals x squared minus 1. So, how do we find an inverse? Okay, step 1 is to switch the x and y. So right now, it says y equals. Instead of writing y, I'm going to replace that y with an x. Instead of saying x squared minus 1, I'm going to make it y squared minus 1. So that was the first step that we are doing there, is that we are going to switch x and y. That was step one, so to speak. And on this first one, I'm just kind of writing in some steps to help you out. Okay, after we switch x and y, officially we're working with the inverse. What do we do to get it in a good form?
Get the y by itself.
Yeah, we're going to solve for y. Get the y by itself. And so that is, so to speak, going to be step 2 is to solve for y. Okay, how would you like to solve x equals y squared minus 1 for y? Yeah, if it's y squared minus 1, how do you move a minus 1? You're going to add 1. If we add 1 on the right, add 1 on the left. What is x plus 1? X plus 1. On the other side, y squared minus 1 plus 1 just becomes a y squared. Now, would you like me to leave it as is, or would you like me to flip the sides? I don't know, can you guys handle it if I go ahead and say, instead of saying x plus 1 equals y squared, if I say y squared equals x plus 1? If you'd rather, make it a second line on yours. Make it a second equation there. Okay, am I done? Have I finished solving for y? Not quite. What's that next step? Yeah, if you want y, and it says y squared, how do we get that squared to disappear? We're going to square root. If we square root the left, we square root the right. What's the square root of y squared? Y. What's the square root of x plus 1? Square root of x plus 1 and plus or minus. Remember, guys, I say this every time I teach this, and I will keep saying it to remind you. When you take the square root in an equation situation, what should you tag on? A plus or a minus. We have to account for the positive and the negative options there. Okay. Did we get it solved for y? Got it solved for y. Officially, the last step said, instead of writing our answer as y equals, what can we write it as instead? Yeah. Instead of f of x, we're going to say f inverse of x. So f inverse of x equals plus or minus the square root of x plus 1. On Math Excel, they'll probably already have that. I honestly don't remember. I haven't been in the homework today, so I don't remember exactly what was in there. Now, okay, it doesn't say it on here, but I know you have to in homework. Again, this morning was kind of crazy. I should have logged in and looked, but you have to answer whether or not these are functions. Okay, so we already talked about a function. Each x is unique, right? We also, I mentioned the vertical line test, right? So if you can draw a vertical line and it doesn't touch, it only touches once, it passes a vertical line test. But we have to decide if this is a function. And this is a little bit more difficult one to think about. I've got some thoughts for you though. So first of all, y equals x squared minus 1. I know it's the original, not the function. Can you visualize a graph for y equals x squared minus 1? What if I just say y equals x squared? Can you visualize a graph for y equals x squared? What is y equals x squared?
Parabola.
Parabola, yes? A right side up parabola, yes? The minus 1 just takes it and moves it down 1. So, for a purpose of a visual, this originally started off as a parabola looking like such. Now, the inverse. If you remember, based on what it said in the directions, an inverse always reflects across what? That diagonal line, yes? So if you have a vertical parabola, a parabola that opens up and down, what happens, can you visualize what happens when you reflect it over a diagonal line? Because if you reflect it over just a horizontal line, it's going to be upside down. Okay? If you reflect it over a vertical line, it's still going to be right side up. What about a diagonal line? It's going to be sideways. Okay, so a right side up parabola is going to be sideways. Now, we don't really deal with sideways parabolas here. But I'm trying to get you to a point of determining, is this a function? Okay?
Am I dying?
I mean, like the only thing I can do is say
Exactly. And not what I really want to listen to. It's also a distraction to you guys. So we're going to close the door. Hopefully. Okay. So if you take that right side parabola, you reflect it sideways, it's now a sideways parabola. What do you know about whether or not this is a function? Does it pass the vertical line test? No, this would massively fail the vertical line test. And so this is an example of an inverse that is not a function. Okay, that one is not a function. Here's another thought. If you're thinking, okay, Mrs. Sargent, that's great and dandy, but I would have never been able to think about that picture like that. Okay, here's my plan B. What happens? I'm going to pick a number of 3. If I put 3 into this function, 3 plus 1 is 4. The square root of 4 is 2. But what's right here? Plus or minus. So what kind of ordered pairs would we have there? You'd have 3, 2, and 3, negative 2. Does that prove to you better that it's not a function? Okay, and here's what I'm going to tell you guys. When you see that plus or minus there, that is a big like red flag saying it's not going to be a function when you have a plus or minus in front of a side like that. Okay, now a lot of these will be more obvious. I understand this one wasn't as obvious, but I also believe it is good to think through. Okay, questions on part A? Okay, let's try part B. Y equals 2x plus 8. First of all, before I get started, can you visualize what y equals 2x plus 8 looks like? What form is this? Y equals 2x plus 8. This is y equals mx plus b, yes? If this is y equals mx plus b, then we know it's going to be a line.
It's a line.
Okay? Intercept of 8, slope of 2. Is that line a function while I'm here? Yeah, that's a function. Okay? Most lines are function unless it's a vertical line. Other than that, lines are functions. Okay. How do I find the inverse? Switch x and y. So instead of y equals, I'm going to write x equals. Instead of 2x plus 8, 2y plus 8. Okay? After we switch x and y, what's my next job? Solve for y. So if it's 2y plus 8, what would you like to do? Subtract 8. So x minus 8 is going to be x minus 8 equals 2y. How do I keep solving for y?
Divide by 2.
If it's 2 times y, we're going to divide by 2. If I divide one side by 2, divide the other side by 2. And we have a couple of options here for that dividing by 2. Notice I just wrote it as x minus 8 over 2. And officially, that could be your answer, x minus 8 over 2. Will Math Excel accept it? I cannot 100% guarantee that. As always, I can never guarantee anything with Math Excel, okay? But that is an equivalent option. What is the other option we can do with that 2? Rather than just put it as one big fraction, that 2 can also go with each piece, right? If we divide that 2 into each piece, 2y divided by 2 is y, then we could also write this as x over 2 minus, what is 8 over 2? 4. And so you could also write it as something like that. For my purposes, I'm flexible. You could leave it as x minus 8 over 2. You could put it as x over 2 minus 4. There are also, what's that invisible number in front of the x? 1. So this is also like saying 1/2 x minus 4. I'm fine with any of those. I can't speak for Math Excel. Okay. Officially, to make this an inverse, what do I do with that y? Rewrite it as f inverse of x equals x over 2 minus 4. You could write it as 1/2 x minus 4 if you want. The question becomes, is this a function? And if I would have left it as x minus 8 over 2, I think it'd be a little harder to know. But based on the fact I said x over 2 minus 4, and I kind of indicated that could be 1/2 x minus 4, what form is this? This is y equals mx plus b again, isn't it? The difference is now I have a slope of 1/2, so it is not as steep of a line. Regardless, it's still a line, and a line is a function. And keep in mind, guys, if you take a line that has a slope of 2 and you reflect it, is it going to change its shape when we reflect it? No, you take an object, you reflect it, it doesn't change shape. It just changes where it is, its orientation. And so if you take that line and you just reflect it, then it's still a line. And so it's still going to be a function. Okay? Let's go ahead and look at C. Y equals square root of x minus 2. Switch them. Step 1 in finding the inverse is to switch them. Meaning instead of y equals, I'm going to say x equals. Instead of square root of x minus 2, I'm going to say square root of y minus 2. Okay. Again, I do this, each one's been a little different so far, which is why I keep throwing these in. Square root of y minus 2. How do you solve for y? How do you get rid of that square root that's hanging out on top of the y? To get rid of a square root, we square it. Okay, meaning, to get rid of this square root, we're going to square it. If I square the right side of the equation, you're going to square the left side. What happens to x once we square it? That's the easy one, right? It becomes x squared. Okay, guys, we've done this on the right. What happens when you square the square root of y minus 2? square root and the square cancel each other out, and it is y minus 2. How do I solve for y? It's y minus 2. Let's add 2. If I add 2 on the left, add 2 on the right. And so I now end up with y equals x squared plus 2. What is a good way to write that? F inverse of x equals x squared plus 2. Okay, guys, use those algebra brains. X squared plus 2. What's a graph of x squared? Parabola, yes, I see the U-shapes happening and hands showing me. The plus 2 just takes it up 2. Well, is that U-shape a function? Yeah, can it pass the vertical line test? A vertical U can't it? Okay. The horizontal U was a problem because it failed the vertical line test. This passes the vertical line test, so this is a function. Okay, that is a function there. Now, again, if you're sitting out there saying, yeah, Mrs. Sargent, I know I'm supposed to know it, but I'm not going to know what x squared looks like. Try plugging in numbers. If I plug in 1, 1 squared plus 2 is 3. Is that going to be anything else other than 3? No. If I plug in 2, 2 squared is 4, plus 2 is 6. If I plug in negative 2, okay, I'm going to get 6 again, but my x values were each different. And so you could do some checking to see if it's a function that way. Okay, so I'm not going to push us because here's the deal. My other 2 classes are behind. They haven't even started the notes. And so I didn't push us. I still had planned to do F, and then I wanted to look at example 3. So I will plan to do that tomorrow. Assuming I have my timing right, 11:45, right? Okay, so this means I will have to go in and change. Hopefully I already changed it so it wasn't coming up due today. Homework will be due Thursday? Does that sound right? Okay. Homework is not due tomorrow is what I'm saying because I'm going to have to go in and finish up the notes. So you are welcome to be working on it. You know a lot of what we're doing. There's just a little bit we'll have to finish up tomorrow. And I would say tomorrow, assuming we are on a full day, you guys could expect some work time tomorrow. Make sense? Because you guys won't have as many notes as my other classes to do. Have a good day.